All right, so here we go. We're going to try this out. So I'm going to do the left one with you, then we'll do the right one. Okay? So I'm looking at that function. Instead of the sequence, I'm looking at that function. Think of the cap. Okay? And that thing, if you looked at it, would look something like maybe... I think it looks something like that. And the sequence would just be the dots. And I'm looking at the function itself. And if I find out that the function converges, what's going to happen with this series? Converge. Okay? So that's positive. It's continuous. It's always going down. Look at a calculator if you want to just see what it looks like. I'm going to do integral test. Okay? So I have to integrate that apparently. You guys know how to integrate that, or we've done it before. Could I do trig sub? Okay? Boom, there's your trig sub. You get to that. Inverse tangent of x. From 1 to infinity. So that's kind of improper, right? I shouldn't really try and plug in infinity. Do you guys remember when I used to write like limit as b goes to infinity? Okay, so I did. Limit as b goes to infinity of that. So I need to plug stuff in. Limit as b goes to infinity, inverse tangent of b minus inverse tangent of 1. What is that inverse tangent of infinity? What's that worth? Do you guys remember? Here's what tangent looks like. Here's tangent. The inverse tangent part is only this, worried about this piece. When does this piece hit infinity? At pi over 2. So I got pi over 2 minus pi over 4, which is pi over 4. Did the integral work? So would the series work? Okay, this is the most common mistake. The interval converges, so the series converges. I think you're good with that. This is a mistake that you cannot say, because all I'm ever going to ask you is, does it converge or diverge? That's all I'm ever going to ask you. I do not ask you, what does it converge to? Do not say the series converges to pi over 4. It does not. All I know is, since the integral converged, the series will converge. I just don't know what it converges to. You guys okay with that? I just know it works. Okay? I don't care what it goes to. I don't want to know what it goes to. I just want to know that it worked. So when I add that thing up forever, it's going to give me a finite number. What is that number? I don't know, but I know it's finite. Okay? What's that? Next week. So for now, all you care about is, can I add this up and get a finite number? Yes? Good. I want those next week. If it doesn't work and it blows up, I throw those away and say, I'm never going to use those. Okay? Okay, next one. Exact same thing, but there's an n on top. Okay? So, here we go. Let's see what I get. Trust me, it's going to be continuous. It's going to be decreasing, and it's we're going to use the integral test. So I'm going to integrate that. Do I need to do trig sub? Nope. So can I do u sub? Yep. So I do u sub. It's a nice u sub. I'm only off by a half. Okay. So I have the 1/2 ln of x squared plus 1. I'm being bad on my notation. I should really say the limit is b goes to infinity or something like that. But I'm really getting 1/2 ln of infinity minus ln of 2. What's ln of infinity? Infinity. So this blows up. Interval diverges, so I know the series will diverge, which means I know this series adds up to infinity and I don't want to use them. You guys okay with that? Okay. Let's look at this one. Okay. Now this one, I like this one because it involves a lot of different things. Okay. First thing I would do is, let's just see if it works with the divergence test. Let's just try right away on this one and just say, oh, let me try a divergence test, because that's the one you should always try. So let's look at the last term. So I'm trying the divergence test. I'm looking at n over e to the n over 2. Okay, and I want to look at when that guy goes to infinity. Do you agree I get infinity over infinity, which is indeterminate? Can I do Hopital? So Hopital, so here comes La Hope. Let's see, the derivative up top is 1. The derivative down low is 1/2 e to the n over 2. That goes to 1 over infinity, which means it goes to 0. Can you tell me if it converges or diverges? We don't know. Remember, it has a chance. It has a chance to converge. That's all I know, remember? You're hoping that was a number, not 0. Boom, diverge. Because why? You guys are losing sight of this. What would that mean? Here's my dots. If it goes to a number, what is all of this going to be added up to? And what's this repeated forever? Infinity. But if it does this, and I go, whoop, 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 do I have a chance that those are going to maybe add up to a finite? Yes. Because it goes to 0 really slowly, like 1 over x. Bad boy. He's not a 1 over x. He looks like a 1 over x, but he's different. Okay? Okay, so next thing, let's try out number 2. Integral from 1 to infinity of x e to the negative x over 2 dx. Okay? Those are finites. Is x always positive? Is e always positive? So the thing's always positive. Okay? It will always be decreasing if you take a look at it. What were my 3 requirements? Positive, and continuous. It's definitely continuous because there's no issues ever with x and e to the x. There's no like asymptotes. Okay? Okay, so I want to integrate this. This is where you assume you know how to do these things. I'm going to do integration by parts. Who do you think is going to be my u? X, 1, 0. E to the negative x over 2. E to the negative x over 2, e to the negative x over 2, and I'm off by stuff. Let's see. This guy integrated, I'm going to be, is that right? And then if I do it again, it's going to be a positive 4. Okay? And then the way you set it up is a plus and a minus. So now this integral is negative 2x e to the negative x over 2 minus 4e to the negative x over 2 from 1 to infinity. Okay? This should remind you of a test like 2 tests ago. How many guys am I going to have? 4. Any issues here? You guys agree with that? Okay? No issues with this part. No issues. Here, there's going to be 1 good and 1 issue. So let's take a look what I mean by that. If you plug in infinity right here, do you agree you're going to get negative 2 infinities times, what's this worth? 0. Minus 4 times 0 minus finite. You can see I don't even care what the number is. I just want to know if the thing's going to work. I'm being very, no. You guys okay with that? So is this part good? So the only part I care about is I need to check this piece. How do I check this whole piece? Hopital. Hop it. So I need to check for the limit as x goes to infinity of negative 2x e to the negative x over 2. Have we already done this guy? Up above. Whoops. That is infinity stuff over infinity stuff. Hop it. You get negative 2 over 1/2 e to the x over 2, which is negative 2 over infinity, which is 0. So is that good? So whole integral converges. Did I even figure out what it converges to? Or did I just check to make sure it converged? Just converged. So whole integral converges, so series converges. You guys okay with that? I don't even know what the integral converged to, because that wasn't what the question was. What was the question? Does the series converge? So that's all I care about, is since the integral worked, the series will work. What's up? Then no, if the Hopital blew up, if a blow up here, if a blow up there, then you would have said series blows up. Okay? So don't stress. If you need to go, that's fine. I'm just going to finish my notes. They're going to be posted online, and maybe tomorrow I won't ask you about your life anymore, and I'll just go right to notes. Blackboard, and I'll post your YouTube notes there. Okay, this one. When I look at this one, I'm going to try and figure out what the pattern is. And this is saying, if you want, you can take a look at that and tell me if this is true. This is the exact same as if I plug in 1, I get 1/3. If I plug in 2, I get 1/5. If I plug in 3, I get 1/7. If I plug in 4, I get 1/9. That fits the pattern. So instead of just giving the pattern, I rewrite it as this series notation. Okay? So this series notation, I'm going to check it with this integral. Let's see, since x is positive, do you agree the function will always be positive? So it's positive. If x gets bigger and bigger and bigger all the time, does the fraction get smaller and smaller and smaller? So it's decreasing. Is there any issues with this fraction? There is. Where is the issue with this fraction? Negative 1/2. Is negative 1/2? Oh, thank you. Oh, thank you. The issue is negative 1/2. Is that inside this integral, though? So it's always continuous on the integral that I care about. So I'm going to integrate. So if I integrate this, hey, this is a really nice u sub. I'm off by 1/2 from 1 to infinity. I get 1/2 ln of infinity minus 1/2 ln of 3. This blows up. Whoops, that blows up. So integral blows up. Integral diverges. So what happens to the series? It also diverges. You guys are kind of okay with that? Okay. So on that one, the only difference was I created a formula from the pattern itself. Okay. So that's the integral test. The p-series test is this one. Okay. It is very straightforward. It is 1 over n to the p, and that's the only form the p-series takes. So at first glance, it might seem very generic and unique and not usable because hardly any of my problems will be this way. but you're going to use the p-series a lot with other tools in the next week. Okay? If p is greater than 1, it converges. If p is less than or equal to 1, it diverges. Okay? We already did all of that with our improper integral notes, where we did the 1 over x, 1 over x squared, 1 over x cubed, and we tried all of those out on the improper integrals. It's the same thing, because this is basically saying if I've done this already in those notes for you on integrals, then this p-series stems from the integral test. Okay? So you're going to have a problem like this, and you're going to go, holy cow, how in the world am I supposed to solve this one? Well, let's come up with the pattern. So let's see, this is 2 squared, this is 3 squared, this is 4 squared, this is 5 squared. So really this would be 1 over 1 to the what exponent? And 1 over 2 to the what exponent is this? To the 2/3, to the 2/3, to the 3 to the 2/3. So this would be the integral, or the series, n equals 1 to infinity, of 1 over n to the 2/3. You guys okay with that? Oh, by p-series, by the p-series, the p is 2/3, which is less than 1. So series does what? Diverges. Okay, because remember, if you take a look at the notes here, if p is less than or equal to 1, diverge. So in this case, p was 2/3, which is less than 1, so the series diverges. Okay, this test is really used with other tests combined, but to understand the basic part of it is pretty quick and easy. Cool. There's the homework. Okay. The homework is page 609, the black stuff. That's all on integral test and p-series test. Yeah, it'll be on Blackboard. And the review set here will help review everything from 9.1 all the way through 9.3, where this stuff is all really about 9.3. Okay? Get used to the review set part. It just will accumulate all of the practice of chapter 9 together. Okay? I skipped the problem. We'll start this problem tomorrow in our notes. Cool. Daniel, hope this helped. Bye.